welcome all beta everyone. Try to share links in maximum groups beta. Okay, lecture will start in a few seconds. In this lecture you will learn what is Euler's explicit formula. Okay, very easy, very easy. Now welcome again, lecture number 9, Euler's explicit formula. As you all know, this is Gaurav Srivastav, Educator Head, Chemic Learning App, Chemic Institute, with 11 plus years of teaching experience to GATE chemical engineering aspirants. So now beta, I am going to start this beautiful lecture. Euler's method. Euler's method. This method is also known as, if in your examination they will write just Euler's method, that means you have to apply Euler's explicit method, and this method is also known as beta Euler's forward method. This method is also known as Runga-Kutta first order. So these all are same to same beta. These all are 100% same, because the main equation of this method comes by forward interpolation. That is why this is also known as Euler's forward method. This is also known as Euler's forward method. I will tell few basics of this method to beta. So pay attention. Suppose you have a beautiful differential equation, dy by dx equals to function of xy. So this was your beautiful equation, and this one is given that yx naught equals to y naught. Okay beta, this is already given with your problem. Okay, now you want to find successive values. So suppose that थोड़ा सा इसका डेरिवेशन कराएंगे, बिकॉज इसका थोड़ा सा इंपॉर्टेंट है, लिटिल बिट इंपॉर्टेंट फॉर गेट एग्जामिनेशन. सपोज दैट वी विश टू फाइंड सक्सेसिवली y1 y2 yn, where yn is the value of y at x equals to xn. What is this y1 beta? This is value of y. This is value of y at x equals to xn. Okay. Now one beautiful graph here beta. One beautiful graph. See, this graph can be asked in your examination. That is why I am going to do this small derivation. केवल सारे मेथड में इसका डेरिवेशन ही इंपॉर्टेंट है. ओके, नाउ सी, they will give you one curve like this and a second one like this. Okay, the above one is beta shows actual value or true value, and this below curve shows us estimated, or it is also known as approximated values. Okay, so this is your x naught, this is your x1, this is your x2, and so on. This is your xn. That means this point shows us y naught, this point shows us y1, this point shows us y2, similarly this point shows us yn. You can see successive approximation. In this manner you are approaching to the actual value with every next approximation beta. And one more thing here, what is this x1 beta? You can see equal interval here. This interval is known as small h beta. Okay, that means again in similar manner, this x1 can be written as x naught plus h. This x2 can be written as x naught plus 2h. This xn can be written as x naught plus nh. Okay beta, and because these all h are very small, I repeat, these all x are very small. एक मिनट रुक जाओ बेटा, जरा रिफ्रेश कर लें, just wait. Okay, done. Now see, because this h is very small, because h being very small, that is in a small interval, in a small interval, any curve looks like a straight line. A curve looks like nearly a straight line. Now see beta, if I am going to take this and this point, you can see looks like a straight line, this and this looks like a straight line. यहाँ पे तो थोड़ा ज्यादा width दिखा है. Here I am showing you little bit more width in this figure, but in actual this h is very small. That means if I am going to take, therefore the equation of the tangent at the point x naught y naught can be written as, you know na, equation of tangent y minus y naught equals to dy by dx, this is slope, multiplied by x minus x naught. I hope each and every student know how to calculate tangent. Okay, now this equation can also be written as y minus y naught. In place of this dy by dx, by equation 1 you can see beta, this dy by dx becomes equals to function of x comma y. So I can write here function of x comma y into x minus x naught, and for y I can write this as y equals to y naught plus function of x comma y. And now because here our point was x naught y naught, so put here x naught y naught and multiplied by x minus x naught. Now this is our formula in raw form. Okay, here the value of y corresponding to x equals to x1 is, you can write this as beta y1 corresponding to x to the power n, your value was yn, so corresponding to x equals to x1, your value will be y1. Okay, so y1 equals to y naught and plus here in place of this x you can put x1, so x1 minus x naught into function of x naught comma y naught. And see beta, this x1 was nothing but x naught plus interval h. So you can see in place of x1 minus x naught you can write h only. Here see beta, you can write h only in this place. Okay, कैन यू रिपीट द ग्राफ सर? बेटा इस ग्राफ में ऐसा कुछ भी नहीं था, हमने आपको बताया कि ये एक्चुअल वैल्यू को शो कर रहा है, ये एस्टिमेटेड को शो कर रहा है. एस्टिमेटेड पे हम ऐसे ही जाते हैं इस मेथड के द्वारा धीरे 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 ये एक्चुअल के पास जाने लगता है। सो वही आपको बता रहे कैसे ढेर सारे जो अप्रोक्सीमेशन आप निकाल रहे हो, सो इस पे सब पे टेंजेंट लेके से निकाला जाता है। यू आर गोइंग टू कैलकुलेट ईच एंड एवरी अप्रोक्सीमेशन विद द हेल्प ऑफ टेंजेंट। ओके, वही आपको बता रहे हैं यहाँ पे। नाउ सी हियर, x1 minus x0 equals to h, you can put here. So this equation will be y1 equals to, और ऐसा जोड़ने की you are going to forward, then this will touch this. This shows your error. This shows your error. What is this? This is your error, beta. This is your error. Because each and every here, this is actual value y here, both coincide because already given with your problem. That is x0 and y0. So both actual and estimated both will be same because given in your problem. Now this is actual y1, this is actual y2, this is actual yn. So you are not proceeding to actual value, actually you are proceeding to next y value at next x, and maybe at some places you can see more error and at some places you can see less error. Okay, wait, okay, now see here, this equation now can be written as y1, and y1 equals to y0 plus h function of x0 comma y0. Similarly, you can write for second approximation. Similarly, you can write for y2. So y2 can be written as y2 equals to y1 plus h f of x1 comma y1. That means your main formula will be y n plus 1 equals to y n plus h function of x n comma y. So beta, this is your final formula. Please learn this formula. इसका डेरिवेशन दे दिया, आगे किसी में डेरिवेशन की रिक्वायरमेंट नहीं है, वो सब आप डायरेक्टली फॉर्मूले के द्वारा देख लोगे. So I am giving you derivation here only for this problem. Okay, now see, I am going to apply this to a beautiful problem, and this is a problem number. One student told me to show me syllabus of mathematics. Wait, अभी पीछे जा ही रहे हैं तो देख लो यार. अरे अरे, तो बहुत धीरे धीरे पीछे जाएगा ऐसे. वेट, this was your syllabus. Okay beta, and after completing numerical differentiation you will complete this one beta. ये complete हो जाएगा this one, numerical methods. Okay, one chapter will be completed. Okay, now see again today's lecture. Wait, okay, this is today's lecture. So now see beta, one beautiful problem. Given that dy by dx equals to dy by dx, and this one problem number, कौन सा problem number है ये? 44. Problem number 44. So dy by dx equals to 1 minus y, given y 0 equals to 0, in the range 0, x is greater than equal to 0, less than equal to 0.3, using Euler's method. Okay, find y 0.3 by taking h equals to 0.1. That means here beta, you need 3 approximation. You need 3 approximation. Now see, it's very easy. बहुत ही ज़्यादा आसान है बेटा. It's very easy. Now we know function of x comma y is given here 1 minus y. Okay, you can see here, and this one is your x naught. So x naught is 0 and y naught is also 0. Okay beta. Now see here, for yn plus 1, formula was yn plus 1 equals to here yn beta, here not y naught. Okay, so yn plus h function of xn comma yn. So first approximation beta, I am going to put n equals to 0. So y1 equals to y naught plus h f x naught comma y naught. ओके शाजिद कुछ कह रहे हैं सर y naught की जगह पे x naught भी आ सकता है ना, अगर आ गया तो कैसे सॉल्व बेटा? ऐसा कैसे होगा, y naught की जगह x naught नहीं आएगा, तो पूरा क्वेश्चन रिवर्स कर देना। अगर x y को आपस में चेंज, अगर यहाँ ऐसे लिख देगा dx by dy बराबर 1 माइनस x, x 0 बराबर 0, तो दैट मीन्स सब कुछ x के लिए कह रहा है सॉल्व करने के लिए, सब कुछ रिवर्स कर दोगे, इन प्लेस ऑफ ऑल x राइट y. ओके बेटा शाजिद, so this is our formula and h is already given, taking step size as 0.1. स्टेप साइज जितना छोटा करोगे आपकी वैल्यू उतनी ज्यादा करेक्ट आएगी. ओके, सो हियर y1 equals to y naught is 0, so 0 plus h is 0.1. function of x naught comma y naught, that means 1 minus y naught, and because y naught is 0, so y1 will be 0.1, 1 minus 0, that means 0.1 into 1, it's 0.1. Wonderful. So you got what is y1, and similarly you can write x1 बराबर x naught plus h, so x1 बराबर 0 plus h, 0 plus 0.1, that means x1 is beta 0.1. okay, now I am going for second approximation. For second approximation, put n equals to 1. So now y2 equals to y1 plus h function of x1 comma y1. Now y1 was how much? It's 0.1 plus h was 0.1, and here 1 minus y1. Why I am writing 1 minus y1? Because my function of x comma y is 1 minus y. Here no x is present. Okay, so it's only 1 minus y. So 1 minus y1, and already told you y1 is 0.1. So after solving, 0.1 plus 0.1 into 0.9, and after solving you will get y2 0. ये कितना हो जाएगा? 9 1 9, 190919. Okay, but this is not your answer. Now x2 will be x1 plus h or x naught plus 2h. Okay, so 0.1 plus 0.1, that means our x2 will be 0.2. now I am going for third approximation. So here put n equals to 2. So now y3, and this y3 is what? This y3 shows us value of y at x equals to 0.3. This y2 shows us what? Value of y at x equals to 0.2. This one shows what? The value of y at x equals to 0.1. And this one shows what? At x equals to 0, that is 0. You can see here given in your problem. This is a limit given that you can apply this differential equation within this range, and already asked only 0.3, that means you can use. Okay, now y3 can be written as y2 plus h function of x2 comma y2. So y2 was 0.19 plus h was 0.1 and 1 minus y2. So y2 was 0.19. After solving beta, you will get here 0.221. So this is your final answer, because you have to find y, the value of y at x equals to 0.3. I hope beta you all enjoyed this lecture, and I am also giving you one beautiful homework. Wait, Yeah, this one beautiful problem. See, take one more problem as your homework. Problem number 45. Because of busy schedule बेटा टाइप नहीं कर पाए थे क्वेश्चन, so no problem. I am writing here problem number 45. Problem number 45, your homework. Okay, so solve dy by dx equals to x plus y with बाउंड्री कंडीशंस ऑफ y इक्वल्स टू 1 एट x इक्वल्स टू 0. ये जानते हो क्या दिया है? ये ऐसे लिख सकता था y 0 इक्वल्स टू 1, ऐसे भी लिख सकता था. ओके, नाउ फाइंड y इक्वल्स टू, सॉरी, होमवर्क थोड़ा सा आपको लेंथियर देंगे, बट इन योर एग्जामिनेशन दे विल आस्क यू मैक्सिमम अप टू y3, बट यहाँ आप ज्यादा प्रैक्टिस कर लेना सो दैट आपको क्लियर हो जाए चीजें ज्यादा बेटर. ओके, बाय टेकिंग h इक्वल्स टू 0.02, use Euler's forward method. They can give you that use Euler's explicit method. They can ask you use only Euler's method. Only Euler's method means Euler's explicit method. And I am giving you answer here beta. Your answer will be y1 you will get 1.02. I already solved this problem. And y2 you will get 1.0405. y3 you will get 1.0624. y4 you will get 1.0848. y5 you will get 1.1081. Okay beta, so I hope you all enjoyed today's lecture, two back-to-back lectures, one of Picard method and second one of Euler's method. Okay, I am showing you both lectures. So this one and this one completed. In next lecture we will cover Euler's implicit method, followed by modified, then predictor corrector method, then Runga-Kutta third and fourth order. Take care beta. This one was Picard method. See summary of both lectures. I hope you enjoyed both lectures. Take care beta. We will meet in next lecture as soon as possible. Take care and don't forget to revise your notes every day if you want a very good rank in GATE examination, any rank between 1 to 100 or rank 1 or 100. So one thing you must learn, I must do my revision daily, 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 I must do my revision daily. Okay beta. Shajid asked me one doubt. Beta Shajid, see, your doubt was on WhatsApp. You asked, sir, why I can't take in Simpson x as 0, 1, 2, 3, 4 for this problem. Problem was like some function of x is here into a dx, right beta? So how you can take 0 to 4 if in your problem limit was 0 to 1 only? You can see it's 0 to 1 only. If this is your graph and you want to calculate area from 0 to 1, then if you are going to calculate area from 0 to 4, then how you will get same answer beta? Your answer will come different now. So here in place of 0, 1, 2, 3, 4, you have to take 0, 0.25, 0.5, 0.75 and 1.0 by taking h 0.25, not by taking h1. This is wrong because you are going beyond your limit. This was your doubt you asked on WhatsApp. I hope it is now clear. Okay, so all the best beta. We will meet in next lecture as soon as possible. Take care. Don't forget to like, share, subscribe with a beautiful comment beta. Love you all. Take care.